Hi, in this video, we will talk about the double angle, power reduction, and half angle identities. Okay, then first, let us look at the double angle identity first. Now, one common mistake a lot of students made when they first learning or use work with double angle, when they see sine of 2 theta, they feel that, or they thought that it is equal to 2 sine of theta. Remember, this is not correct. One thing about this is this 2 right here related to the function is the amplitude. This 2 right here is related to the period, right, of the functions. So that means these two, they are different meaning in this case. Okay. So if if you do something like this, okay, and then you feel that, oh, I could cancel the 2 and then make it become sine of 2 theta. Remember, this is not correct. Okay. Okay. So how do we actually take care of the double angle uh, properly then? Okay. Then when you see sine of 2 theta, it is equal to 2 sine of theta cosine of theta. Okay. Wow. Why this happened? Okay. Then we have to go back to the last section that when we learn sine of alpha plus beta, which is sine of alpha cosine of beta plus sine of beta cosine of alpha. Okay. So now then take a look. If I have sine of 2 theta, meaning it is equal to sine of theta plus theta. Okay. And now if I replace alpha and beta with theta, okay, like this, then I will have sine of theta cosine of theta plus sine of theta cosine of theta. Okay. Because this one and this one, they are the same. So I could add them together, become 2 sine of theta cosine of theta. Okay. This is exactly how we get sine of 2 theta is equal to 2 sine theta cosine of theta then. Okay. Similarly, if I have cosine of alpha plus beta, then it is cosine of alpha cosine beta minus sine of alpha sine of beta. Okay. Then now cosine of 2 theta, it is cosine of theta plus theta. Okay. Again, we replace alpha and beta with beta. Then we have cosine of theta minus sine of theta, sine of theta. So then, of course, we have cosine square theta minus sine square theta then. Okay. Again, don't make the mistake with this cosine square theta plus sine square theta. This is equal to 1. Okay. However, cosine of square theta minus sine square theta, then it is equal to cosine 2 theta. Okay. And again, based on the Pythagorean identities, we know that the sine square theta is equal to 1 minus cosine square theta. Okay. So now, if I replace the sine square theta with 1 minus cosine square theta, Then let's see what do we have. Mhm. Then in this case, I will have cosine square theta minus 1 plus cosine square theta. Then we got 2 cosine square theta minus 1, okay? Which is what we have here, okay? So then keep that in mind. Cosine 2 theta, we have 3 ways to write the cosine 2 theta, okay? And of course, if you remember like tangent alpha plus beta, then you will be able to find the tangent 2 theta then, okay? Okay. And now let's see how do we work with the power reductions now, okay? Again, the idea about the power reduction is now you see that the left-hand side, the power of the expression that we have is a square, okay? Sine square theta, right? And then to the right-hand side, do you see that the power is 1, okay? So this is the idea about the power reductions then, okay? Okay, and how do we actually get the power reductions? Okay, basically, we are going to again work with these two then. Okay, okay. So let's see, we get it here first. So if I have 1 minus 2 sine square theta, which is equal to cosine of 2 theta. Okay. And now we are going to subtract 1. Okay. And now we are going to multiply both sides by -1. Then I will have 2 sine square theta is equal to minus or negative cosine of 2 theta plus 1. Okay. Or 1 minus cosine 2 theta. Then if we divide both sides by 2, then I will have sine square theta is equal to 1 minus cosine 2 theta over 2 then. Okay. So you can work it out, okay, almost the same like our first our example, okay, about sine square theta. Then you will be able to get cosine square theta is equal to 1 plus cosine 2 theta over 2 then. Okay. And now tangent square theta will be, if I have, okay, tangent square theta, basically it will be sine square theta over cosine square theta. Okay, so meaning I have this one over this, then you see that 2 and 2 cancel. Then of course I will get 1 minus cosine 2 theta over 1 plus cosine 2 theta then, right? Hmm. Okay. Then the last is how I got the half angle identities. Okay. Then let us get it from sine square theta equal to 1 minus cosine 2 theta over 2 then. Okay. So in this case, if I want to solve for sine of theta, what I can do is actually I could take the square root to both sides of the equations. Okay. But remember, if we take the square root, we will have plus or minus, right? Always. Okay. And now, if I let theta equal to alpha over 2, then you will see that I have sine of alpha over 2 is equal to plus or minus square root of 1 minus cosine of 2 times alpha over 2 over 2. Okay. Then you will have plus or minus square root of 1 minus cosine alpha over 2 then. Okay. So then we show that sine of alpha over 2 is equal to plus or minus square root of 1 minus cosine alpha over 2. Okay. And now when we work on the problem, okay, how do we actually take care of the plus or minus? This plus or minus is related to alpha over 2 here. Okay. So when the plus or minus sign is determined by the quadrant of the angle alpha over 2. Okay. So if alpha over 2 is the angle in quadrant 1, then of course we will have positive. Okay. And so on and so forth.